Hi, in the last videos I talked about functions. I explained what a function was, I gave examples of functions, then I talked about plotting functions and finding the roots of functions. Now I want to give some sort of real world, just a simple real world example of what a function is and how it can be applied. And the reason why I want to do it is because having some real world tangible kind of examples really kind of helps you to remember what it is. So it's not just something abstract. So it makes sense that it would have some sort of practical application. And for this, I want you to imagine we have a cake shop, okay? So we have a cake shop, and they sell cakes, right? So here's a cake with some candles and stuff, right? Okay, so um, and we want to now look at the two functions we found, this linear function that we found here and the quadratic function. So this was our linear function, and this was our quadratic function. And let's now just talk about these two examples in this real world kind of case, okay? So let's imagine here that our x variable here, so x is equal to the number, and I do this hash sign for number, the number of cakes. We'll imagine that you can sell half of a cake and a quarter of a cake as well, so you can chop the cakes up, okay? And then f of x is going to be profit. So the amount of money that the cake shop makes. Okay, so what they do is they try to figure it out. So they figure it, they say, well, on one day, we sold 10 cakes, and this is how much money we made. On another day, we sold 20 cakes, and they keep putting in these numbers, and they realize all these points that they put down, they're all on a straight line, and then they kind of figure out what they're, then they figure out this kind of function for it here. And what they realize is, oh, okay, you know what? We have this sort of, we have this function here. We have a linear function. It just keeps going up and up and up. So, basically, the rule that they figure out is the more cakes that we sell, the more money we get. Real simple. Now, it could be, just imagine for a second, it could happen. Maybe it's not a cake shop. Maybe it's something else. And instead of their function just going up and up and up forever, it could go up and it could saturate. It could just find a limit and it could just stop there. There are examples of functions that saturate. In which case, it wouldn't really make sense to make, you'd find some sort of value and then you wouldn't make any more after that value, okay? So that would be an example of how you say, okay, we make this number of cakes and then we stop. But in this case here, what happened was they found that this was their function and it just said, the rule of thumb that they took away was the more cakes the more cakes that we make, then the more money that we make. So we're just going to make as many as we can, okay? Okay. Now the next one is, let's say this is all about ads, okay? So this time x is equal to the number of ads that they take out on whatever various places where they can put ads. So this is the number of ads, and now f of x is again equal to the profit, okay? And they realize, okay, well look, if we don't do any ads at all, so they're up here like this, right? And they have a point here, right, on the axis. They're like, this is how much profit that we can expect to make. Let's say they say, we're going to make some fixed number of cakes a day. And they're like, if we make this fixed number, this is the profit that we can make, right? But maybe they don't sell all the cakes, right? So maybe they're actually looking to also advertise to get more people to come in. Now, X is the number of ads. They realize, actually, you know what, if we spend all the money on one single ad, more people come in, but actually the cost of the ad, we actually end up losing money. Right, but it seems to be at that point it doesn't make sense to run an ad, because if you run an ad, then you just end up making less money, right? But then you could run a second ad, and then it's actually twice as expensive, but you actually end up making less money again. But they realize, after having figured out this function here, that they need to put out some threshold number of ads. They have to put this, and then they start to. Then the additional people who start to come in, then it starts being kind of worded. And then actually, by the time you get back over here again, right, for this value here, you have to be x critical, we'll say. You have to have this critical value of x. Beyond that, then that's it. So if you were going to bother putting some ads out, you would have to have this number of ads out in order for it to make sense, in order for it to be to make extra profit. Okay, so maybe a silly example. It doesn't also really matter if the example's silly. what's important is that you connect the abstract ideas that you come across in mathematics to sort of everyday kind of examples. It basically stops the maths from being so abstract, and it makes it more understandable. Okay, so that's all I want to talk about on this topic. Um, okay, so that's all I want to say about functions for now. Um, okay, so that's all I want to. So that's all I want to say about functions for now. In future videos. Okay, so that's all I want to say about functions for now. All of these points we'll come back to again in future videos.